Hello everyone, today in this video we'll be discussing the module 2 of machine learning BCS602, and in this module we have the following topics. Okay, I'll be telling you what all the topics you need to know from the exam point of view such that you can easily score more than 80% marks. And if you have any doubt, you can ping me on Instagram here. And before starting, please do like and subscribe, it helps me make more videos like this. So without wasting more time, let's get started. See, the first topic is the bivariate and multivariate data. In the previous module we had discussed the univariate data. You remember what is univariate data? Univariate means one variable. Okay, one variable. For example, there is students marks. Okay, students marks, and it is given in the form of a chart. Okay, like this, it is increasing. So the student mark is only the variable here. The student id is irrelevant, because student id is not related with the student marks. Okay, because of student id, student mark will increase, like that it will not happen. Okay, so the student mark is only the criteria which is there, so it is univariate. Bivariate means it will be dependent on two variables. Okay, bivariate data deals with two variables. An example is in the change in sales with respect to temperature. If temperature is more, the sales is lesser, because if it is more hot outside, people will not go for sales, right? So this is the thing. Temperature is one variable and the sales is one variable, so two variables involved here. This is called as the bivariate data. Now the graph can be plotted here. Scatter plot graph is used to indicate the bivariate data. So here the points are marked with respect to temperature and the sales. As you can see, there is a decline when the temperature is increased. So this is the observation which we get to know. Okay, and it can also be represented in the form of line graphs. Okay, if we just make a line between those dots, we'll be getting a graph here. Okay, so this is called as a line graph. Two ways in which we can represent the bivariate data, which is the scatter plot, and second is the line graph. Okay, next, the two measures are used to calculate the bivariate statistics. Okay, two measures are there. Means statistics means what? The analysis of the data, whichever the data we have, to analyze the data, what it means. Okay, to get to know what it means, we use statistics. So two measures are used. First one is the covariance. What do you mean by covariance? Suppose that there are two variables, random variables x and y. Covariance is the joint probability. What is the probability that x and y both are true? That kind of probability. Okay, so covariance of x, the formula is given here. Okay, and e of x and e of y is nothing but the mean values of x and y values. Okay, and covariance of xy is equal to the covariance of yx. And an example is also given here, you can go through it. Okay, so this calculates the covariance. Okay, it is just for the teaching you how it is. Okay, it is not from the exam point of view. In exam, like these questions won't be asked. Okay, what will be asked is the theory questions here, and this is just for explanation purpose. Okay, you don't need to memorize this one or practice this one. Just understand here, x is given, y is given, and what is happening, the mean is calculated and the covariance is calculated here. Second one is correlation. Okay, it measures the strength and direction of linear relationship between two variables x and y. Suppose that there is a worker. Okay, there is a worker, and the worker builds a wall in 10 days. Another worker is there, he builds a wall in 5 days. Okay, if these both workers work together, it will be 15 days or 5 days. Okay, it will be 15 days or less than 15 days. It will be less than 15 days, because if two workers work together, time will decrease. Number of workers is increasing, time is decreasing. Listen again, number of worker increases, the time is decreasing, right? This is called as a correlation. Correlation between the two variables. If one increases, is the other decreasing, or is the other increasing only? If suppose that there is a bowl. Okay, in that bowl there is a soup. Okay, it is of 20 degree. If I add water which is of 50 degree, both will be added up and it will become more temperature, right? So adding more water increases the temperature. So that is the correlation between them. Both of them are increasing. Okay, and other one is whether you add it or subtract it or whatever you do, increase or decrease, it will not change. That is independent. Okay, so three things are there. If value is positive, means both things increase. If it is negative, means one is increasing, another is decreasing. And if it is zero, means whether it is increasing or decreasing, it doesn't matter, the other one will be independent of it. Okay, so that is called as a correlation, and this is a formula used for the correlation. By using covariance and the standard deviations, the sigma x sigma y, will be able to calculate the correlation between x and y. Okay, so here is an example, you can go through it. Okay, this was about the bivariate. Now we are dealing with the multivariate. Multivariate means more than two. Okay, so suppose that there is an id which depends on attribute 1, attribute 2, attribute 3. Okay, so the attribute values are also given here, like that. Another id is there, another id is there, so this is dependent on three attributes, so it is a multivariate. And to calculate multivariate things, we'll be calculating the vector mean. Vector mean means that what is the mean value of 1 2 3? It is the 2, right? 6 divided by 3. What is 4 5 6 mean? It is 15 by 3, which is 5. What is 1 2 and 1, which is the 3 by 2 plus 4, 4 by 3, 4 by 3, whatever the value comes, that is the mean of it. So we'll be calculating the mean of each of these values. That is the vector mean. Okay, and to represent these values we use two methods. Like the previous bivariate we used scatter plot and the line graph. Here we'll be using heat map and pair plot. So basically heat map is nothing but there will be colors here, okay, and more darker the color the higher the value. In this way we can able to understand like here is more, here is more, here it is more, here it is more within one glance. Okay, so this is what is the heat map. Okay, and next one is the pair plot. In pair plot also we'll get to know how dense it is, in which place it is more means there is more data. Okay, there more correlation is there, like that we'll get to know. Okay, so that is the graphs used for the multivariate data. Now to understand and learn the multivariate data, three things are needed. You need to understand three things in mathematics. Okay, because machine learning is very closely related to mathematics. The first thing you need to learn is the linear systems and Gaussian elimination, because this will be used in multivariate data. If you don't know this you can't deal with machine learning. Okay, so linear system means what? Ax is equal to y, variable multiplied by another variable, we are getting another variable. So to find out the value of x value we'll be have to find out the inverse of a multiplied with y, right? So this is just for a single system. If there are multiple system means there will be a matrix. Okay, a1 a2 a3 a4 a5 like that, there will be matrices, and again the value is same only, y1 y2 will be there. In order to find out the value of x we will have to find out a inverse into y. Okay, so this is called as the linear system. Okay, and to solve the linear system we use Gaussian elimination. Okay, so these are the steps which will be followed in Gaussian elimination. Let's quickly go through it. Write the given matrix, okay, and then append the vector white matrix A. Okay, this is called augmentation matrix. A is called as an augmentation matrix. Then we'll do operations on each of these elements. I'll explain what is the operations. It can be either subtraction, addition, multiplication, or division. Okay, and we'll repeat the same logic and reduced echelon will be formed. Okay, and then we'll be using back substitution to find out the value of more accurate echelons. Okay, so an example is given here. This is the equation given, two equations. So convert this into a form of matrices. Okay, after converting your matrices you will be dividing by 2. Okay, this all the rows you'll divide by 2. Okay, so it becomes more simpler. Okay, so when we divide 2 by 2 it will become 1, when we divide 4 by 2 it will become 2, when we divide 6 by 2 it will become 3. So here r1 is equal to r1 by 2, so first row is getting divided by 2. Okay, done. Now again we will be performing some operation like subtraction and division here, such that it becomes in the form of ones and zeros. Then it will be in the reduced echelon form. We can write x2 is equal to 1 and x1 is equal to 1. Okay, what these final two values we get, that is the echelon values of x and x2 and x1. Okay, for these two equations which you have been given. So we had to find out the x1 and x2 values. These are the x1 and x2 values. Once we have a echelon form, like for example 1 1 and 0 0 like this, if it is there means this is the x1 and x2 values. Okay, that is the Gaussian elimination method. Second thing you need to know is the matrix decomposition. Decomposition means making smaller. Okay, so to make a matrix smaller, okay, this is the matrix given, we have to make it smaller or make in the form of ones and zeros. To do that we will be multiplying it with a identity matrix. Okay, 1 0 0 0 1 0 0 0 1. When you do the matrix multiplication we'll be obtaining some values, then we'll be applying a row and row elimination operations. When we keep on doing we'll be obtaining a value here, and this value is nothing but we'll be having the 1 minus 3 and minus 10 by 3. This will be the answers. Okay, this is a lower triangle, this is the upper triangle. Okay, when we mix them both we'll be getting the final answer. This thing you need to know. Okay, this is the matrix decomposition. This is all the theory parts. Okay, don't try to understand what is happening, just get to know what is the steps being performed. Okay, next is the third one is the probability and statistics. Without probability and statistics you cannot learn machine learning. Okay, so let's discuss the probability distribution. Means what? If a graph is there, which part of the graph has more values? Okay, that kind of distribution is called as probability distribution. Here more, here it is less. Okay, that kind of distribution is called probability distribution. Okay, two types are there, discrete and continuous. Discrete deals with the single digits 1 2 3 4 5 6 like that, points will be there. Okay, and continuous means it will be like a graph. Here it can have the fraction values also. Okay, so first let's discuss the continuous probability distribution. In that comes normal, rectangular, exponential distributions. So first one is the normal distribution. It is a continuous probability distribution, also known as bell-shaped curve distribution. You might have seen in the mathematics, right? It will be having a curve like this. Here the probability is less, here the probability is greater in the middle, and here also it is less. So the formula is used for the normal distribution is this one. Okay, next one is rectangular distribution. Rectangular will be like this. Okay, it will be nothing here, it will be full here, it will be nothing here. So this kind of distribution is called rectangular distribution, and this is the formula. And exponential distribution is used to describe the time between the events. Okay, at time t1 something had happened, at time t2 something had happened, observations at this and this, between them what had happened. Okay, to calculate in between them what had happened with what probability, that will be using this formula. Okay, so this is the Poisson's distribution we'll be using here. Okay, it is also called as exponential distribution if it is discrete. If it is if it is continuous. If it is discrete we'll be using the Poisson distribution. Let's have a look at the discrete distribution. Here we'll be dealing with the integer and the numbers. Okay, Like for example, we'll be dealing with true and false values. Okay, so binomial distribution is the first one. Here the two values only will be there, true or false. Okay, objective of this distribution is to find the probability of getting success k out of n trails. N trails will be performed. Like for example, I will be tossing a coin 10 times, 5 times head has come, 5 times tail has come, so my probability is 50-50%, like that. Okay, finding out that using the binomial distribution. This is the formulas and these are the derivations. You can go through it. Okay, next is the Poisson's distribution. Given an interval of time, this distribution calculates the probability of given number k. Means if there is 1 year, okay, 1 year, I'll be telling you previous year this many accident has happened, another year what is the probability that this many accident happen in the month of August. Looking at the previous data, we'll try to check what data could be most probably. For that, this formula is used. Okay, next is the Bernoulli's distribution. In this also the same thing happens. The true and false values are there. Q is the negative value, which is the outcome of negative value, and P is the positive outcome. Okay, so based on this we'll be able to calculate the distribution. Okay, that is the Bernoulli's distribution. So this was about discrete and continuous probability distribution functions. Next we have density estimations. To estimate the density, it is a problem of estimating the density function from an observed data. I have given you a tabular data. Okay, here rows and columns values are there and values are present here. Now based on these values you have to calculate what is the density. Density means which kind of values are more closely there. Okay, means it suppose that there is a tourism data. In tourism data, I've been given in each month how many number of flights are there. To calculate the density, I have to get to know which is the month where the highest number of flights are there. It will be like a summer vacation time, right? So where data is more dense, that is the probability density. How can we calculate the density using our observed data? There are two methods. One is parametric and another one is non-parametric. Parametric means we will be given the values what we want to calculate. Like for example, we want to calculate the flight data, the maximum flights. Non-parametric means flights will not be given. They will be giving you all the things like number of people visited, number of cost increases, number of food taken, and number of flights. So based on this they will be seeing which has more density and that will be considered. That is non-parametric. So in parametric, two formulas are there, I mean three are there. Maximum likelihood estimation. Here what happens is it is a statistical method for estimating the parameters of a probability by maximizing the likelihood function. What is the likelihood? You define it first, then you take the log of it and then you maximize it. Okay, this also is the theory part. Okay, next is the Gaussian mixture model. Here it assumes data is generated from multiple Gaussian distribution with unknown parameters. It is commonly used for clustering. Okay, and this is the formula of it. Next is the EM, which is the expectation maximization. Here in Gaussian method we don't know what is the component getting generated, so we use EM algorithm to maximize the probability which we are going to get, and this is the formula for it. Okay, next is the non-parametric. Here two are there, Parson window and the KNN. Parson window means n samples will be there. Okay, like for example n fruits are there. Okay, and I have k samples from total of n samples. From n samples I took k samples. Now the probability of that will be k by n, obviously, right? So if there is a volume of the region R, okay, V of a hypercube. Okay, you don't need to know actually what it is, just understand what it is. Okay, V is the volume of the region R of hypercube, and how do you calculate the value of hypercube? H cube for the 3D cube, H square for the 2D square. Okay, and this is the probability function given. Okay, we'll be applying this function to calculate what is the probability if a sample is present inside the window or not. This is a window. Okay, we are defining a window. If a sample is present inside or it is present outside, that probability is calculated by using this formula. Okay, and last is the k, which is the k nearest neighbors. So if this is a thing, here how many neighbors are there? If this is a thing, how many neighbors are there? If this is a thing, how many neighbors are there? These are different clusters, and whichever has the most neighbors, that will be considered. That is called as KNN. Okay, so these things you need to know from the mathematical perspective of machine learning. Okay, next comes feature engineering and dimensionality reduction techniques. What is feature? Feature is attributes. Like for example, the feature of elephant. Elephant has a husk or not, elephant is big or not, elephant is having legs or not, elephant is having a tail or not. Okay, those things are the features, attributes. Okay, and what is feature engineering? It is about determining the subset of features that are form an important part of the input. Means elephant has 100 attributes, but I am only concerned with 10. Which are the 10 most important attributes? That subset finding is called as feature engineering. Finding out those 10 most important ones, that is called as feature engineering, and it deals with two problems: feature transformation or feature selection. Feature transformation means new feature creation. If I have two features and by using these two features I'll create a new feature. For example, elephant eats grass and elephant drinks water. I can make these two into a combined one. I can tell that elephant is a vegetarian. Okay, like that I can find out a new feature by using the existing features. Next one is is feature selection. Selection means, as I told you, there are 100 features, but I am concerned with only the most 10 important ones. So selecting those, what algorithms you use, that is called as feature selection. Okay. And now feature could be removed based on two aspects. Okay, we have to select the best features, remove the worst features. Listen again, in feature engineering we'll select the best features and we'll be removing the worst features. Okay, we don't want worst features, we'll be removing it and we'll be selecting best features. To remove the worst features, there are two methods. Feature relevancy, whichever the feature is relevant, keep it. Irrelevant, remove it. Elephant, it can walk in the ground. Okay, that is an irrelevant feature because all animals can walk on the ground, so I'll be removing that. Feature redundancy, what is the date of birth of elephant and what is the age of elephant? Both are redundant because either one is sufficient for me to calculate the other one, right? If I have the date of birth, I can calculate age. If I have age, I can calculate the date of birth. So feature redundancy will be using to remove the unwanted features. Okay, so procedure is generate all possible subsets. After doing all the above things, we'll be getting many subsets, and then we will be seeing which subset is most relevant one, and we'll be using that in the model. Okay, so these are the three methods in the feature engineering. Next is dimensionality reduction. What is dimensionality? How many attributes are there? That many dimensions. If something has 3 attributes, it is 3 dimension. If it is 4 attributes, it is 4 dimension. Now we are removing unwanted dimensions so that only we have relevant dimensions to calculate on. And the lesser the dimension, the better. Listen again. The lesser the dimension, it is better one. Okay. We have to select the best ones. Okay. That is the first step. Select initially have an empty set of attributes and go through all the attributes and select which are the best ones. The other one is stepwise backward elimination, means you will have all the features and you will be keep on removing bad features one by one. Okay, that is called as stepwise backward elimination. Okay, next one is principal component analysis. This I'm discussing the techniques of the dimensionality reduction. So PCA, which is known as the principal component analysis. Here we will be just selecting those components or the features which are the best ones. Okay, for that some formulas are there. Okay, first let's consider a random vectors of the form this. Okay, now mean of this will be E of x. Okay, and covariance can be calculated using this formula. If it is a large enough data, we will be having to calculate the eigenvalues. Okay, so by using this formula you will be able to calculate the eigenvalues. Covariance matrix is real and symmetric, so if ei and lambda I are the eigenvalue and eigenvector, then transform kernel A will be found. Okay, we need these two values to find out the kernel, and these two values how we get? If it is a larger value, and we will be able to calculate it. Next, after finding out all of this, we will be mapping the vectors y to x to y using the transformation described as follows. And this transformation is also called as Card-Union Loewe or Hotelling transformation, and this is the formula of this that one. Okay, and if eigenvalues are involved in this, k is the largest eigenvalue, then A of k will be used. Observe here, A is not specifically mentioned here. Here it is mentioned A of k. Okay, and the advantages of P of PCA are immense because it helps us to calculate the only relevant features from a large set of features. Okay, so the algorithm is also given here. Can go through it. Okay, this is very straightforward. Whatever I explained, it is the same thing. You have to calculate the matrix, find out the mean value, and obtain the data set. If it is having the large data set, obtain the eigenvalues and eigenvector, apply the formula, and find out the answer. And after all of that, okay, final, what is the biryani we will be getting? Okay, we have all the ingredients. We made a biryani. Okay, what is the biryani of this topic? The biryani of this topic is that 6 out of 246 attributes are important. These many attributes were there. You had to calculate and consider this many, but you applied PCA because why? You are a smart person, so you just got 6 attributes now. So only 6 attributes are relevant, and among 6 also the first 3 are more than 50% relevant. The higher the eigenvalue, the important the attribute is. Listen again, the higher the eigenvalue, the important the attribute is. So this saves so much time. Okay, so that's why PCA is used. From 246D we converted into 6D. Okay, now we are concerned with just 6 dimensions. That is such a massive amount of time saved, right? And here is an example. If you are interested, you can go through it. Okay, the same thing whatever I explained, it's there in the numerical form. Okay, this will not be asked in the exam as such, it is just for your understanding. Okay, another technique we use is the linear discriminant analysis, LDA. What it does, it also does the same thing, higher dimension data to lower dimension data. So here two classes we'll be using, C1 and C2, and nu1 and nu2 is the mean of those values. We'll be using these values for the nu1 and nu2, and we'll be substituting in the Jacobian function and finding out the answers of the standard deviations. Okay, and then we'll be doing the maximization also, and we'll be finally getting a value. So this is also another technique, LDA. Okay, we have singular value decomposition also. Here also the same thing will be done. Okay, so here are the steps, and A is the matrix which we want to calculate. U, S, and V are the things we will be considering here, and these are the formulas and the steps which you need to know. The columns are U and V. Okay, You can go through it, and here is an example for that as well. Okay, so these were the methods which we'll be using for dimensionality reduction. The next one is design of a learning system. Okay, what is a learning system? A system that is built around a learning algorithm is called as a learning system. Okay, and it focuses on these steps. Choosing a training experience. Training experience means if a chessboard is there, how a chessboard is played. Okay, and choosing a target function. In chessboard, what is the final output I am expecting? That is a target function. Representation of a target function. How is a target function represented, and function approximation. These two things we'll discuss. This is just the input and output part. Okay, so to determine the target function, we'll be using the weights. Okay, weight will be multiplied with the inputs. X1, X2, X3 are the inputs. W1, W2, W3 are the weights. Okay, inputs can also be taken as the features. Okay, this is how we represent the function. Next is choose an approximation algorithm for the target function. We'll be using this function so that it will be minimizing the errors. Okay, and we'll be using the updating formula, which is wi is equal to wi plus nu into error into b into xi. Okay, and the learning system has the following components: performance system, critic system, generalizer system, and experimentation system. Four systems together form a learning system. Okay. Next is concept learning. Concept learning means classifying an object that has the common set of relevant features. There are many features, and which is the common features we'll be selecting and classifying it. Okay, that is called as concept learning. Each concept or category can be either true or false value. Like for example, if I ask you, are you tall or not, it can be either true or false, right? So that is a concept. Okay, one feature. So concept learning requires three things: input, output, and test. Okay, so this is a table which will be extensively used. This is a table basically about an elephant. Okay, elephant, and the features are given like size, hoovers, color, and so on. And the instances are observed. There was an elephant who had no horn and tail was short, tusk was there, paws was not there, fur was not there, color was black, hooves was no hooves were there, and size was big. This is one elephant observed, and this was another animal observed, which is also similar to elephant but not exactly. So it had these features. Another elephant was observed with these features. So based on these features, we will be approximating what kind of features we can consider that will be most probably mapping to an elephant. Okay, so that is the input is this one and the output is this one, and these are the independent variable, this is the dependent variable. Why it's a dependent variable? Because elephant is dependent on the size, hoof, color, fur, paws, tusks, tail, and horns. Okay, now representation of a hypothesis. Hypothesis means what? It is a conjunction of the attribute values. Okay, the attributes will be there. Okay, for example, if this is an elephant, right, the conjunction of this hypothesis is there, which says that it is not having horn, the tail is short, the tusk is there, the paws is there, fur is there, color is black, and hoofs is not there, and size is big. If this is there, that means it's a most probably an elephant. That is one hypothesis. Okay, we'll represent hypothesis using the following symbols. Question mark means any value it can take. Okay, and null means no value it can take. Short means that specific value. For example, a hypothesis H will look like this. H is equal to no, question mark, yes, question mark, question mark. And this is, as for example, if this is true, that means an elephant can have no horns. That is specified here. And tail, some elephant might have tail, might not have tail. Question mark means any value. Null means it will not have any value. Means tusk means if null is there means no elephant has no tusk. Okay, like that. Okay, and question mark means it can have the tusks or it can not have the tails, like that. Okay, yes and no both can be possible. Null means none of the values can be possible. Okay, it is not applicable only. Okay, so if all the question marks are there, this can classify as elephant because all the values which are present there all can be put in the question marks. Question mark can include any values, yes or no, also it can include tail is there or not, both can, it is accepting. So all of the accepting values can include elephant also, but that is not a best solution because it can include any animal. So what is special in that? Nothing is special. So something should be specific so that we can say that it is an elephant most probably. Okay, so most specific hypothesis will be null. Okay, that means none, no animal can be an elephant. If this is all null means whatever attribute you give, it is not an elephant, like that. Okay, that kind of thing it is there. Okay, now there are two things here, the concept learning, specialization and generalization. So basically concept learning will be taking concept input will be 5 instances, which I just discussed in the upcoming in the previous table. That has 5 instances and the attributes are given. Output is it an elephant or not? Hypothesis, as I just discussed, which are the attributes which will be there, which will be classifying the elephant as true or not. Okay, and the combination of all of this will be giving us the output, and h of x is equal to c of x, hypothesis of x and the concept of x. Okay, the next topic is the hypothesis space. Okay, hypothesis space is a set of all possible hypotheses. As I discussed in the previous one, that hypothesis will be having here, that will be including some specific value or all the values or none of the values, right? So that combination is called as a hypothesis. Now, how many such hypotheses can be formed? Okay, for example, each of these 8 attributes has these values. Okay, so if you try to calculate how many total all values could be there, it will be 384 all possible instances. Okay, and we can use the question mark and the this value also, right? So it will become 4 into 4 into 1 into 5 into 4 into 4. That will be 81,000. Okay, so this many hypotheses can be generated. Okay, so this is called as the hypothesis space. Next is heuristic space search. Okay, it is a search strategy that finds optimized hypothesis or solution to a problem by iterative improvement. Okay, here in heuristic, what will be there? There will be a cost associated. Okay, it will be having a secret cost value. We will be using the secret cost value to calculate a final answer. That will be called as heuristic space search. Okay, heuristic means the knowledge of the context. Okay, next is generalization and specialization. Okay, for this concept, the following table is referred. Generalization means what? All the question marks. Okay, it can include any animal. Okay, in this example elephant is also included. Specialization means specifically, like big, okay, and black, and fur is not there, like that. These specifications, how much we do more specifications, that is more specialized, like that. Okay, so an example will be seen to illustrate specific to general learning. Now what we are doing is specific to general. If they give you a table in the exam and they ask you to do from specific to general, that means generalization. Okay, if they ask you to do generalization, what you have to do? Start with a hypothesis with all the specific ones. Okay, because we are going from specific to general, right? So specific means all the null values will be there. Then consider the first iteration. Okay, iteration first means this one. Okay, and remember, if you are going from specialization to generalization, we'll be ignoring the no values. Okay, this will be ignored, this will be ignored, only these three values we will consider. Okay, and what we need to consider, wherever yes is there, yes is a positive instance, no is a negative instance. Okay, the output variable which is there, in that yes is the positive and no is the negative instance. Okay, now see, we have taken all the specifics here. Okay, now we have what we have got here: no, short, yes, no, and so on. Okay, so this is specific one, but we have got a general value. We are moving to a generalization. Okay, so whichever values are there, these are more general than these null values. Okay, null means nothing, this means something, right? And something is more general than nothing, so we'll be considering this one. Okay, so hypothesis will become entirely this one. No is there, we'll not consider it, we'll ignore it. So third one, when we go, whatever the values are present here, we'll be checking with the previous hypothesis. Okay, previous hypothesis, what we have got here, h1, no, short, yes, no, no, black, no, big. Okay, now we'll be checking this one. No, no, okay, it is same. Short and short, this is also same. Yes and yes, it is also same. No and no, this is also same. No and no, this is also same. Black and black, this is also same. No and no, this is also same. But here it is big and here it is medium. This means that elephant can be big also, it can be medium also. So we cannot put one value. We have to put question mark because it can be either big or medium. So this became question mark. Previously it was big here. Now that became question mark because medium is also taken into consideration here. No value we will ignore. Then the third one, which is yes. Here again the same thing will compare. These values will be comparing with the iteration value. Okay, the previous hypothesis with the iteration value. Wherever a difference is there, they will put question mark. This is no here, but here we got yes, so question mark is coming here. No is here, but here it came yes, so question mark is here. Black and black remain same. No and no remain same, and question mark was here, and here it is big. If it is a question mark already, will not make any difference. We'll keep it as question mark only. Now this is a generalized value. Okay, this you need to understand. Like that, in the reverse way, we do for the general to specific, which is also called as specialization. Okay, so here what we do, since it is general to specific, first general is there, right? So we'll take all the question marks. Then now what we'll do, this is a instance we'll be taking. Okay, and this is the h1 value hypothesis. Okay, now here we'll consider both yes and no. Okay, here we'll consider both yes and no, and this is a bit complex, but listen to me carefully. I'll try to explain you as much as I can. Okay, now see, here is the instance given. Okay, and the general values are given here. Now if the instance is given and the general values are given, we need not do anything. Okay, we'll keep it as such. Okay, h is more general to classify all instances to true. Okay, so this will be kept as such. Next what you have to do is, here we'll be comparing with I2. Okay, only one iteration is not sufficient to start with h1. We have to consider I2 also. In I2 you just compare, this is no, this is yes. There is a difference here. Okay, and there is a difference here means this is no, right? See, listen to me carefully, this is yes. Okay, means these are the values of elephant. Okay, and this is not the value of elephant. Okay, so what do you get from these two instances? If it is an elephant, there is a no here. If it is not an elephant, there is yes here. And we are trying to go to specific. Okay, from general to specific. So we need more accurate values for elephant. Okay, that means this should be no only, right? If it becomes yes, it is not an elephant. If it is no, means it's an elephant. So what do you get to know? You get to know that this value is specifically no only, right? Because if it becomes yes, it will not be elephant. Okay, like that we'll put here as no, and we'll do one attribute separately. Okay, one attribute we'll do separately. Next attribute we'll consider short. Here also it is short. Here it's also it is short. Don't do anything. Just consider those which are difference. Here it is yes, here it is no. Which means what? It is yes. Yes for elephant and no for not elephant. So we are specific, we are looking for what is an elephant. So yes will be taken here. Next one. There is no and no, don't do anything. No and no, don't do anything. Black and brown. Here is the difference. If it is black, it's an elephant. If it is brown, it's not an elephant. So I'll take black here. Okay. Again, no and yes. I'll have to take no here, and big and medium I'll take big, because whatever is the elephant values that will with that only will I'll be considering. Okay, now we have got h2 here. We'll consider the third one is also yes. Now we'll compare this and this. Okay, now here I have already no here, so here also it is no, so no worries. Okay, then short was previously also it was short, so it is a question mark, we need not worry about it. And here we have a yes, and here also we have a yes, no worries. No, and here also it was question mark, no and question mark here, no worries. Black and black, it is fine. And it was no here, and here also we got no, fine. And here it is big, and here we have got medium. Okay, so see here, big was here in the previous case, big was that which was considered. Now here medium came. Okay, so what we will do is we'll just keep it as big only. Okay, because previously we had got as big, right? So we'll be keeping here at as big only. Okay, we'll not make any change to that. Okay, next again negative instances here, and in negative instances we'll remove all those which are inconsistent. Okay, remove any hypothesis which is inconsistent. Till here you got the point, right? See, if you are confused about this one, medium came here, but we have kept it as big because previously we had got here as big, right? That was for yes. Okay, so even if medium comes, we need specific value, so we'll not be changing it. Okay, just that it is. Okay, now I4 is a no. No means we'll have to compare this and previous hypothesis. Now previous hypothesis is this one. Okay, now no is here and no is here. Okay, both are same. So if both are same, you have to ignore it. Why? Because if no is an elephant, no is not an elephant, so no became doubtful. So no row we have to remove. This one will be removing. Got it? Now long is here and short is here. It was question mark, no need to worry about it. Yes. Okay, yes was here and no is here, so there is a difference. Yes means it's an elephant, no means not an elephant. We'll keep that value. Okay, then question mark, no need to worry about that. Here it was black means yes elephant, white means not elephant, so it is again a strong indicator that black is a elephant only, so we'll keep black here. And next it was no here, so I mean it was question mark here, so we need not worry about that. And last one was here, it was medium or big, it was there, both are elephant only, so we will not make any changes, we'll keep big as elephant only. Okay, done. Last one is a yes means a positive instance, and we'll be comparing this one with the values which we have got. Here it's all question mark, so no, it does not make any difference. Here all question mark, so short also does not make any difference. Here it is yes, and here also it is yes, so we'll retain yes. Question mark, ignore. Black is here, so we'll keep black here. And no, there's a question mark, so we need not worry about that. And here we have a big, and here also we got a big. So these three hypotheses which we have got, this is called as single hypothesis. Okay, this is the final answer of the specific one. So what we are sure of is that the yes is present here. Yes means whatever the attribute is for that, and it is a black and it is big. Okay, if these three attributes are there, most probably it is an elephant. This is the thing which we have come to a conclusion. Okay, this is how you do the generalization to specialization. The next topic is the find S algorithm. Okay, find S means find specific. So we are going to find a specific hypothesis in this algorithm. Okay, so the input is positive instances in the training set. Whatever the instances are there, that is the input, and output is one hypothesis which is the most specific one. Okay, first step is to initialize the H to most specific hypothesis, so it will all be null. Okay, this is the most hypothesis. Then generalize the initial hypothesis for the first positive instance. Whichever is the positive instance and whatever the values are there, fill those values instead of this. That means generalizing. Okay, for each subsequent instances, do two things. If it is a positive, then only consider it. Second thing is, if it is same, don't do anything. If it is not same, means two positive instances are there with different values like yes and no here in some of the attribute, then make it to question mark. That's it. Okay, so for the given data set, we have to apply find S algorithm to find the answer. Okay, so here what we will be doing, here how many yes are there? First yes, second yes, third yes. We will not be considering this one. Okay, this one we will be ignoring. Now we will be checking each. Okay, very simple. Greater than 9, greater than 9, greater than 9. So it will be finally here, it will be greater than 9. Okay, then yes, yes, yes. Okay, so it will be yes here. Excellent, good, good. So there is a difference, so make it as question mark. Good, good, good. Okay, so make it as good only here. Fast, fast, slow, so there is a question mark here. Yes, yes, and no, so there is a question mark here. There's difference, that's why. Yes, 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 so it will be yes only. Okay, so this is how you do the find S algorithm. Now there are three limitations of find S algorithm. First is that it tries to find a hypothesis that is consistent with the positive instances, ignoring the negative instances. That is first disadvantage. Second is find only one unique hypothesis while there can be many. And third is training dataset might contain some errors. Okay, in that case the find S algorithm will give us the wrong answer. Next topic is the version space. Version space contains all the hypotheses from a set of hypothesis space that is consistent with all the training instances. Means all the possible answers. That is the version space. Okay. So an example to use in the version space is list then eliminate algorithm. The idea is to list all hypotheses then eliminate one by one. But this is not feasible because it is very difficult to implement practically. That's why we have candidate elimination algorithm. So in candidate elimination algorithm, we'll have to do two things simultaneously. What we'll be doing is first we'll be having a general algorithm and then we'll be specifying it. Okay. And another one is we have a specified algorithm, we'll be generalizing it. And when doing these two things, we'll be setting boundaries. One boundary for general, one boundary for specific. To be as general as possible, to be as specific as possible. Next, what happens is we reach a point where we have the most specific one and most general one. Then we will see what is the comparison between these two and how many permutation and combination can form in between this, and that will be the version space. Okay, so an example is given here. Before that, this is the algorithm, you can go through it. So basically what we do, input is a set of instances, output is the hypothesis G and S. Okay, initialize G to the maximally general and S to the maximally specific, and then generalize the initial hypothesis for the first positive instance. Then for each of these instance, what you do, generalize S if it is positive. Okay, and check the attribute value. If it is same, then keep it as such. If it is not same, then put it as question mark. Then prune G to exclude all inconsistent hypotheses. Okay, and if it is negative, that means specialize G to exclude the negative instance, because G will exclude the negative. You have to specialize to exclude the negative from G. Okay, then add G with minimal specialization to exclude the negative example. If it is different, then fill it with the S value. If it is same, then you need to keep it as question mark only. Okay, then remove all inconsistent hypothesis from S. Okay, if you see the example, you'll understand. Okay, the algorithm write 3 times, you'll get to know. Now see, this is the training data set. Now what you have to do is you have to do the specialization as well as generalization at the same time. So generalization, initially it will be question marks. Specialization, it will be null values here. Now for the first iteration here, we are going to do the generalization for specification, right? For S1 we will try to generalize. That means the null values will be converted to the first set of values, and this one, it is a general value. It is a general value, we have to make it more specific, so it will be question marks only. Okay, so it is more general, it will be question marks only. Next is, again in I2 we will consider I2, the positive instance will consider, and a change has happened here from excellent to good, so it will become question mark. S2 is becoming more general, so it became question mark, but G2 is becoming more specific, right? But since there is no change, it will have still question marks only. Then it's a negative instances, we have to ignore the negative instances. Then the third one, there is no inconsistent hypothesis in S2 with the negative instance, hence S3 remains same. Now G3 will change. Why? Because the negative instance had come, and after that this is going to be considered. Okay, and the S3 value is here. This is as same as the previous one. Okay, and these values you have generated based on what remained the same. Okay, so greater than 9, yes, and yes. These three remain same. Other all changed. So we'll keep it as such. Okay, next. Fourth one also we'll be doing the same thing, and we'll be getting whichever is the same and different. Based on that, specification will be generalized and generalized will be specified. Okay, so based on that, we'll be finally reaching a point where we have the version space as this. Okay, so this is my final answer. But if we see diagrammatically, S1 became like this, then S2, then S3, then S4. Okay, this is S4. And if we go from the reverse, G1, G2, G3 it became. Okay, so G3 finally it became into 3 because 3 things had remained same and other all changed. So whichever changed, that has to be denoted by question mark, right? So then we have the this value and this value. Okay, because this is inconsistent, we will be ignoring it. Okay, so we'll have these values, and from this one we obtain 3 values. Now the combination permutation between these values, which is the specific values and the general values, the combination between this is the version space that includes all the possible hypotheses which are valid. Okay, Next topic is modeling in machine learning. Now machine learning things we have learned. Now how to put that in the whole thing in a model. That is what is called modeling in machine learning. Okay, so we'll be using this formula to reduce the errors happen during the execution. Okay. Next, four steps are there. Choose a machine learning algorithm and suit the training data and the problem domain. Input the training data set and train the machine. Okay, to learn the data and capture the patterns. Then tune the parameters to improve the accuracy of the model. Then evaluate the learned model. Okay, so to choose a model, the following steps are followed. Use resample methods and split the dataset as training, testing, and validation. Then do the evaluation thing and check the performance. The simplest approach is to fit a model on the training dataset. Already an existing model is there, try to fit it in the dataset. Else, the third option is the use of probabilistic framework or quantification of the performance. Model is using the third approach, which is as a score. Okay, we'll be sometimes using a score also. Okay, now what are the different methods here? The resampling method means that select a model by reconstructing the training dataset and test dataset by randomly choosing the instances by some method from the given dataset. Okay, we are randomly choosing the dataset. Some of the methods in the resampling are random test splits, train test splits, and cross validation, which include k-fold and LOOCV and bootstrap. Okay, so what is cross validation? It is a method by which we can tune the model with only training dataset. Okay, by using only training dataset, we can tune the model. But how will it happen? Okay, we'll be using the LOOCV. Okay, leave one out, cross validation. This will be discussing in the upcoming topic. Also, we can use holdout method, k-fold cross validation, and stratified cross validation. The important ones are holdout, k-fold, and LOOCV. Okay, so how holdout method means what? It is simplest method of cross validation. Okay, the data set is split into two subsets called the training and test data set. Okay, so the whole data set is divided into two parts, training and test data set, and then the evaluation will be happening on that. So this is the holdout method. Second is the k-fold cross validation. So here what happens, the data set is divided into k parts. Okay, and creating k minus 1 subsets. Out of this, whichever is used for the training, that will not be used for the testing. Okay, based on this, we'll be getting the performance of the k iterations. Okay, each iteration one will be considered. Okay, so this is the example given here for this. So here we have the fold 1, fold 2, 3, 4 till fold k, and here test fold came, then here test fold came, in the third iteration test fold came. Whenever the test fold is being applied here, it will test all of these elements and then we'll be getting the answer. So the algorithm is as follows. The input is the data set with n instances and k number of folds. How many ever the folds are required, we'll be holding it and folding it, and then we'll be splitting the data set into k equal folds, train the model, evaluate the model. Okay, then compute the average performance of all the k k holdout folds. Okay, the LOC will leave one out cross validation. This method, what it does, it splits the n data instances of the dataset into training dataset containing n minus 1 data instances and leaving one data instance for evaluating the model. So n minus 1 are there for training and one dataset instance is for testing or evaluating. Okay, so this is the training dataset. We will be going through all the datasets and then we will be leaving out one for validation. So here is the algorithm for it. So here we have repeat the following n steps to hold out the data instance for evaluation. Train the model on n-1 data instances and evaluate it on one remaining holdout. Okay. Next is the model performance. How do we get to know what is the performance of the model? Okay, so for that we used contingency table that will show us what is true positive, false negative, and true negative. Now, what is true positive? True positive means this thing is present and the machine has detected it correctly. That is true positive. False positive means this thing is not there but machine has detected it is there. That is false positive. False negative means it is there but a machine has not detected it. And true negative means a machine has detected it but it is not there. Okay. So these are the different performances we will be using: true positive, true negative, false positive, and false negative. If you want more information, you can read this part. Okay, here it will be making it more clear. Now there are seven or eight methods we'll be using to calculate the performance. First one is sensitivity. It is the probability that will produce a true positive value. Okay, when the test is on the database set. So TP by TP plus FN. Okay, and specificity. What is specificity? The specificity of the test will produce a true negative result when used on a test data set. Okay, so it is Tn by Tn plus Fp. Next is positive predictive value and the negative predictive value. So we'll be having Tp at the top here and Tn at the bottom here. Okay, and then accuracy. Accuracy is the true positive plus true negative divided by all the things. Okay, whichever showed as true, that will be the accuracy. Precision, Tp by Tp plus Fp. And recall, it is same as sensitivity, which is Tp by Tp plus Fn. So whichever is given here, these are the metrics we'll be using for calculating the performance of the model. Okay, and we can also classify the performances based on the distance measures. Okay, ROC is nothing but receiver operator characteristics. AOC is area under curve. Okay, so area under curve, how much more it is, that is more better. So as you can see, best is E, right? So area under this curve is all of this. Okay, so it is the best one. The next best is still better thing. Okay, still better means it will be having the area under this one. Okay, this is also still very good. Okay, but not best, better than E. Okay, so that is one of the things which can use to classify the performance as distance measures. The last one is scoring method. Okay, in scoring method, what we'll be doing, we'll be combining the complexity of the model and the performance, okay, of a score. Then the model is selected by the model selection is done by selecting the model that maximizes or minimizes the score. So we'll be using minimum description length, MDL. That is one such method in which we'll be able to find out the minimum description length. Okay, so the formula is given here. It is if H is the learning model, LH be the number of bits, then the model is given as LH plus L of D given H is occurred. Okay, so we'll be getting the MDL final value as minus log P and theta minus log P y x theta. Okay, so these are the values, which is y is the target variable, x is the input variable, and theta is the model parameters. Okay, so these are the scoring methods used for evaluation of the model. That's all for this video, and if you found this video helpful, please like and subscribe. It helps make more videos like this, and thank you so much for watching. I'll see you in the next one.